Today we will be attempting to solve LeetCode number 19. Remove the nth node from the end of the list. So we are given a head of a linked list, and we need to remove the nth node from the end of the list and return its head. So let's say in this example we have the list and n is equal to 2. So we need to remove the second node from this list and simply return the new list after deleting the nth node. So over here we have our linked list, and the solution we will use is actually 2 pointers. So let's make a left pointer and a right pointer. We need the distance between these 2 pointers to be equal to n. So we will traverse the list until r is 2 or n distance away from the left pointer. We then traverse the list until r, the right node, is equal to null. When r is equal to null, we are on the node that we would like to delete. But the problem here with a linked list is that you can't actually delete the node by having access to the node. You need to have access to the node right before it. So how we delete it is that we reassign the pointer to the node after that. So after we reassign the pointer, we have effectively deleted the nth node. So in this case, n would actually have to be the distance would actually have to be n plus 1 in this case, which is 3. And also, to simplify the edge cases, we would have it in our best interest to make a dummy node pointing towards the head. So let's say this is the dummy node. We then make L and R equal to the dummy node, and then using the right pointer, we traverse the list until the distance is equal to n plus 1. In this case, we need to be 3, so 1, 2, 3. When the right node is at the distance of n plus 1, we then traverse the list until r is equal to null. So when r is equal to null, we then take the node that L is pointing to, and then we reassign the pointer to the node after that. So we have basically deleted the nth node from the back of the linked list. So now let's go into LeetCode and actually solve the problem. So how we write down this code is that we first create our dummy node, which would be equal to list node. So we're making the node, and we'll make the node equal to 0. Now we need a pointer for the dummy node. So we then say dummy.next will be equal to head. So the dummy node will be pointing to head, the head of the linked list. Now we'll make our left node, and we'll make it equal to dummy. The left pointer, sorry. Now we'll make our right pointer and make it equal to dummy also. So in order to traverse the list and make the right actually be n plus 1 ahead, we then make a for loop. So we actually say for in range n plus 1, the right pointer will be equal to right.next. So if n is 2, the right will go next 3 times. When that loop is done, we then need to traverse the list until the right pointer is equal to null. So we can make a while loop saying while right is not none, right will be equal to right.next, and also left will be equal to left.next. So they're both traversing the list until right is equal to the null, until the right pointer points to null. And then when we're done, the left pointer should be on the node before the one you want to delete. So the way we reassign the pointer is we say left.next is equal to left.next.next. So this is how we reassign the pointer. And then we need to return the head, which would in turn return the list. So we say return dummy.next. And this will be pointing to the head. This is how we return the head. So now let's run the code. And it works. So now let's submit it to see how efficient it was. And as you can see, the solution is pretty good and works well. So if you liked this explanation, please like and subscribe, and I will post the code in my GitHub with an explanation. So stay tuned, and thank you and goodbye.